Hi, my name is Jessica Cahoot, and today I am going to show you how to build a smart water system. And a smart water system is one of the many STEM projects that you can use to introduce your students to engineering design and coding. It also brings in some real-world elements because it deals with some real-world problems. One of the real-world problems that we're going to be dealing with today is drought. And so trying to figure out ways to deliver water to agriculture systems that is sustainable and that we're only using the right amount of water. We're not wasting any. So whether it's dealing with drought and famine or building a sustainable garden that's within your community, an activity like this where you're building a model and using engineering design, coding, can really give students some really valuable skills. And so the design challenge of this one, we're going to be using environmental conditions for our plants, and we're going to determine how much water those plants need based on those environmental conditions. And we're going to be using a programming language called TI-Basic to write a computer program to control the input and outputs of our program. And so there's an engineering design process that we're going to be involved in. So we have to define the problem. We have to figure out how we're going to water these plants. What conditions will they need? What conditions will be right for watering? And how much water are we going to be delivering to these plants? Students will get a chance to design a solution, figure out what the conditions are, how much water it needs, and when the watering is going to be ideal. They'll have a chance to get feedback from their peers to improve their design. They can then build and test their designs, and then they can also present on their ideal solutions. So it really helps them get a little taste of how engineering design works, and they can practice some of their coding skills. For this project, we have several different components. We have some inputs and outputs. So the inputs for this, with using the TI Innovator Hub, we're going to be using the soil moisture sensor, the temperature and humidity sensor, and the light input sensor. And so we're taking in that information to determine what our plants need. And then our output sensor or motor is going to be our water pump. So it's a submersible water pump that we can then put water out at a specific speed or amount. And so based off those conditions that we're taking in, we're going to determine how much water is going out and when. And so we are using TI-Basic for this particular activity today, but TI has just come up with a new operating system for the TI-Nspire CX2 that includes Python. So in future activities, your students could use the programming language of Python to create some of these projects. But today we're going to be using TI-Basic for simplicity and my personal skills. So I learned how to code through TI Codes and 10 minutes of code. So it's a very easily accessible way to learn how to code. So some of your students may never have coded before. Some of your students may already know Python. But TI-Basic and TI Codes is a great resource to go to learn some of the early skills of coding, to get exposed to it. So you don't need any coding skills to get introduced to a project like this. 10 minutes of code is a great way to kind of just introduce yourself and your students to some basic skills. And this project can be tiered to help your students based on whatever level they're on. So if they have no coding skills whatsoever, they can still be successful. And so when we think about our engineering design process, we need to define that problem. And so if we're trying to determine how much water we need to give our plants, we need to think about what plants need. So what is the ideal temperature? What's the ideal humidity? What is the ideal moisture, and when should we water and when shouldn't we? And so we start developing this criteria for us to think about and our students to think about in developing our code. And to develop our code, we need to understand how our sensors work. So our sensors, our light level, our temperature and humidity, and our soil moisture are all our input sensors. And then our water pump is our output sensor. And so we need to understand how to write the code for each of the sensors, what information those sensors are going to be taking in, and then how we can then control our water pump. And so for my students, what I would do is I would give them each of the sensors, allow them to play with the sensors, gather information about how they worked, learn some basic programming and what kind of information these particular sensors would take in, what kind of code they would need to write in order to get that information, and then figure out what to do with it. So this is an example of the light level sensor where the first line of code says send connect to light level 1 to in3. And so this is just saying that there's a light level sensor plugged into the TI Innovator Hub at the input port number 3. And then that second line is just taking in that information from a range from 0 to 100. We've set up a for loop where we're going to be reading the light level, getting the light level, and then displaying the light level. So even your students that are just learning how to code, teaching them to just interpret what the code means is a great first step in kind of getting the logistics behind everything and the logic behind everything so that they can be successful in this project. We also have the digital temperature and humidity sensor, where again, we're going to be putting it into our input ports, this one in import port 1, and then we're going to be reading the temperature, reading the humidity, which this sensor can do both, and then we're going to do something with it. And then for our soil moisture, we're going to be connecting this to our input port number 2. We're also going to be collecting that information in a range from 0 to 100. We're going to read that moisture sensor, we're going to get that information, and we're going to display that information. So these are very similar patterns between all three sensors that the students can become familiar with, so that when they start putting it all together, they understand why and what's happening. For our output, we need to tell our output to turn on and turn off, and we need to develop certain parameters to do that. But with our output sensor, our water pump, it has the line of code of saying connect analog out 1 to out 1. So what this means is that our water pump is our analog out, and we're using one of them, and it's going to be plugged into our output port 1. And so by putting all this information together, our students can hopefully develop a program to help them turn on a water pump with the right parameters. When is it going to be the most ideal condition to do so? So I want to show you what a completed program could look like. And this is an example of the TI-Nspire CX Premium Teacher software, where we could see what this would look like on a student handheld to give you an idea of what students might experience. So on page 1.1, we just have a schematic of the hub and the inputs and outputs that we've seen before. And 1.2, we have the full program. And so we've defined our program name as Smart Irrigation, and then the program is listed below. And before we get into what the program means, the reason I really like TI Basic and coding on a calculator is that it's very accessible. You don't have to memorize any of the syntax. It's menu-based. So if you look over on the left-hand side to the calculator and hit menu, you have a list of options that you could start editing and adding to the code. And I teach my students that we use a few of these quite frequently. Like the control menu. The control menu is all those if-then statements, the for loops, the while loops, our I/O statements for our inputs and outputs for our display that we use. And then also we're using the hub. So the hub is going to have its own set of commands in which it's going to be interacting with those sensors. And so everything is accessible through these commands through a menu, which makes it a little bit easier and less need for memorization of syntax for the coding. So what we have here for this complete program, we have these notes that are kind of this gray area. the notes aren't read by the program, but they give us some insight on what the code means, and which is really important for kids just learning how to code. It kind of gives them some insight on what's happening, and it's just a really good way to understand why that code is there and what's happening within it. So for this first set, we're just connecting the inputs to the hub. So we've got our light level, our digital humidity temperature, and our moisture, and they're connected to those 3 ports in the input. We then have those 2 sensors, light level and moisture, that have specific ranges that we're going to be taking in from 0 to 100. And then we have our output, which is our water pump. And so that's connecting our analog out to our output 1. And so this is just kind of a reminder of all of what it's supposed to tell us and all of what it's supposed to do. Now, our temperature and humidity sensor has a small section here to kind of help warm it up, that this code is there specifically for the sensor, and it's going to warm up the sensor. Once it's ready, it's going to display sensor ready, so we know we're ready to go. And then there is a while loop, and in this while loop, it's going to help us collect this data. And while we're collecting this data, it's just going to be easy to break the code by just hitting escape. And so that's the purpose of the while loop here, is just to make it easy. Everything, it's just going to be reading everything, and then once we're ready to end the program, we just hit escape, and it makes it much easier to end the program. So we're reading the light level, we're getting the light level, we're reading the moisture, we're getting the moisture, same with the temperature and humidity, and then we're displaying them. So we have it set up where we're displaying the temperature and what it is, the humidity, what it is, the light, what it is, and the moisture and what it is. And then we're also displaying to press escape to end the program, just to remind ourselves that we've built that in. And so we want to then put in information about what we want to do with our pump. So we've got this information. Now what do we want to do with it? So we've just set it up very simplistically with just light and moisture. So we could also add temperature and humidity because we have that sensor as well. But just for the simplicity of this demonstration, we're just looking at light, which we've selected for less than 10, and moisture for less than 5. So it needs to be dark and it needs to be dry in order for the pump to come on. And so if the light is less than 10 and moisture is less than 5, this would be a good condition to pump. So we have an if, then, else. So if we have those parameters met, then the pump is going to turn on and we're going to display this is a good condition to pump, or else we're going to display this is not a good condition to pump and the pump will not turn on. And so after this is going on, it will continue to go through this as long as those parameters are met or not met. And the only way to stop this program again is to press that escape key to break the program. And so let's see it in action. In this setup, we have our TI Innovator Hub with our N1, N2, and N3 ports. We're going to put our light sensor in N1. There's our light sensor. Our temperature and humidity sensor in N2, which will measure both temperature and humidity. And then our moisture sensor in N3. So those are all of our inputs for this project. Then on the output side, we have our output 1, which will use our water pump sensor. And our water pump sensor is fully submersible in water. It's connected to a MOSFET with a battery pack for some extra power. And then we will need to connect our handheld to our hub. And so the cable will go into the data port of the hub, and we'll be able to see that it's connected because we'll see the lights come on, and we know it's ready to go with that green light is stable. Once our program is loaded and written, we're going to go ahead and hit Control R for run, and we'll see how this all goes. All right, so we are ready to go. Our program is complete. All we have to do is hit Control R to run our program. So our program then opens up into a separate calculator page, and all we have to do is hit Enter. So our sensors warm up, they start displaying, and we also see that it is not a good condition to pump. So the temperature is at 23 degrees Celsius, our humidity is at 73, our light level's at 96, and our moisture is at 0.01. So our moisture levels are low and our light levels are high. If you remember from the parameters we set up in the code, we didn't touch temperature and humidity, but you could. Our light level had to be below 10 and our moisture had to be below 5. So our moisture is where we want it, but our light level is too high. So in order to fix this, we need to make sure that our light level decreases. So if we put our moisture level in and we lower the lights, we can see if we can get that light level a little bit lower, getting it closer. So our moisture level is still pretty low, but if we lower the lights, we can see if we can get that pump to turn on. And so slowly, as we decrease the light, it will slowly get darker and just needs to be a little bit more dark. There we go. And now the pump turns on because the light level is lower than 10 and our moisture level is now 100. So it stopped. So that was just one of the many STEM projects that you could do with your students, and a very abbreviated version of it as well. So I highly recommend that you go to www.TI-Stemprojects.com to see what other projects are available to you and your students, and then just starting off with 10 minutes of code to ease into this process of learning how to do engineering design and coding. And your students will thank you for it. They have such a great time expanding their knowledge and learning new skills that will hopefully help them in the future and guide them into careers they may never have thought they wanted to do before. So thank you, everyone, and have a great day. Bye.